In 2 days, 3i Atlas passes within 29 million kilometers of Mars. That sounds like a safe distance, but here's what nobody's discussing. The minimum orbit intersection distance, the closest this thing gets to Mars's complete orbital path around the Sun, is only 2.7 million kilometers. Avi Loeb called this remarkable fine-tuning. When a Harvard physicist uses those specific words, you need to pay attention. The HiRISE camera aboard the Mars Reconnaissance Orbiter will image 3i Atlas with a resolution of 30 kilometers per pixel on October 3rd. That's detailed enough to separate the nucleus from its surrounding dust cloud. Detailed enough to measure the actual surface area reflecting sunlight, and detailed enough to confirm whether this object is really 5 kilometers across, like Loeb's latest mass calculations suggest. If it is that large, the natural comet explanation collapses entirely. Based on the limited reservoir of rocky material in interstellar space, we should have detected roughly 100,000 smaller interstellar objects on the scale of Oumuamua before finding something as massive as 3i Atlas. But we've only found 2 previous visitors. Both were tiny compared to this. Here's where things get genuinely disturbing. Loeb calculated that if 3i Atlas deployed a precursor probe, a smaller scout craft traveling ahead of the main object by approximately 30 million kilometers, that probe could intercept Mars on October 3rd or during the week preceding it. And here's the terrifying part. Earth-based telescopes cannot detect objects smaller than about 100 meters at Mars distances. That's roughly the size limit of all spacecraft humanity has ever launched. Any precursor probe would be effectively invisible to us,